Good morning, students. This is Ansari Yasmin, and students, today I'm going to teach you scattering of light from standard chapter. Uh, Students, let's first understand what is scattering of light, and for this, I'm going to show you a small demonstration which you can do at home under under your parents' guidance. Let's start. To perform this experiment, we need a laser light, a milk spoon, dropper, and a beaker containing water. Now what we need to do, we will use a laser light and we will pass this laser light from the beaker containing water. We can observe that I can we can see the light entering into the beaker. We can see the light exiting from the beaker, but inside the beaker the path of light or the beam of light is not visible. Now what I'm going to do, using a dropper, I'm going to add few drops of milk to the water and I'll stir it. After stirring, I'm going to again pass the laser beam into a, from the water, and now I can see the laser light. The beam of light is visible inside the beaker also. The path of light is clearly visible. So why does it happen? What happened when I passed the laser beam through a plain water, and what happened when I passed it through a turbid water? Turbid means when I added drops of milk into the water becomes turbid, and when I passed a beam of light through turbid water, it is clearly seen in the turbid water as compared to the plain water. Students, when I added drop of milk into the water, the milk contains molecules, protein molecules and other molecules it contains. So when the beam of light collide to these molecules, you can see here when the light strike or collide with these molecules, the light ray gets scattered. You can see the scattering of light here. So this water which contains milk molecule, when the beam of light is passed through such water, because of the molecules, the beam of light gets scattered, and when the scattered rays enter our eyes, we perceive this light. Initially, earlier in the first example, when the water was plain, so there was no scattering of light as no molecules were present, so we were not able to perceive the light. But when I added drop of milk into it, because of the scattering from the molecules, we can perceive the light. So the same concept is related to the sky. We all know that sky appears blue in color, the sun appears yellow in color, and the sun appears reddish or orange at the time of sunset and sunrise. So let's find out answer for these questions. But today in this video we are going to understand the first concept, why does sky appears blue in color. Students, we all know that the light coming from the sun is a white light, and we also know that white color consists of 7 colors: violet, indigo, blue, green, yellow, orange and red. These are components of white light. You can see these colors, these rays are in the form of waves, and you can see these colors have different wavelength. If you will check the length of each color's wave, the violet color wave is smallest, and you can see the red color wave is the bigger one. biggest one actually. Violet is having smallest length. Indigo is it is having comparatively greater wavelength to violet. Blue color's wavelength is more than indigo and violet. Green color's wavelength is more than blue, violet, and indigo. And in this way, you can see the red color is having the biggest wavelength. Here you can see violet color and blue color. The Here you can see the distance between the two wave is called wavelength, and it is denoted by lambda. The wavelength of violet is small compared to wavelength of blue, and the red color wavelength is biggest amongst all. Students, we all know that our earth is surrounded by atmosphere. Our atmosphere consists gases, dust particles, water droplets, and water vapors. Our atmosphere is made up of all these things. It consists of some gases. You all know that nitrogen, oxygen, carbon dioxide, and some inert gases are present. Dust particles are also present in our atmosphere. There are water droplets and water vapor too. You can see the composition of gases in our atmosphere. Oxygen is 21%, 78% nitrogen, 1% carbon dioxide, and some other gases. So these gases, dust particles, water vapor are in the form of molecules. So when the white color light coming from the sun strike to these molecules of atmosphere, these molecules absorb sunlight, and after absorbing it re-emits the light in various directions, and this re-emitting of light in various direction is called scattering. You can see, suppose these are the molecules of gases or water vapors or water droplets or dust particles. So the light coming from the sun strike to these molecules. These molecules absorb this sunlight, and after absorbing they re-emit the sunlight in various direction, and this re-emitting of light in various direction is only called scattering. So because of this atmosphere, the scattering takes place. According to Rayleigh law of scattering, the intensity of scattered light is inversely proportional to the fourth power of wavelength of a wave. Let's understand this. Intensity of scattered light, that is I, is inversely proportional to fourth power of wavelength of wave. Inversely proportional means if wavelength is more, scattering would be less. Inversely proportional. How it is inversely proportional? It is inversely proportional to the fourth power of wavelength of wave. So if the wavelength is more, scattering would be less. If wavelength is less, then scattering would be more. Okay? So here you can see amongst all these 7 colors, the violet color wavelength is least. It means violet color will scatter more, and red color wavelength is the biggest wavelength, and hence the scattering would be least here. So when the sunlight strikes to the atmosphere containing some molecules, scattering takes place, and more scatter the color which scattered more is the violet color, then indigo, and then violet. Here you can see the maximum scattering is of violet color. So we can see here violet color's wavelength is least here, and hence the scattering of violet color would be more than indigo and then blue. But sky does not appear violet, it does not appear indigo also, but it appears blue in color. So if we will see, the scattering of blue color is most, if you will see the spectrum, and this is because human eye, our eye, is more sensitive to blue color than violet and indigo. Hence, even though the scattering of violet and indigo is more as compared to blue, but the sky appears blue because our eye is more sensitive to blue color compared to violet and indigo. So this is the one concept based on scattering we understood. Now in the next video I will explain you why does sun appears yellow and why does it appear reddish or orange at the time of sunrise and sunset. Till then, bye. Thank you.